welcome. I see a lot of very familiar faces here in the audience, but also a lot of new faces, so welcome. Oh. So just as an introduction, my name is Karis Mitchell. I'm the interim director here at the Chesapeake Biological Laboratory. And I've been here 24 years. And I actually started out in the Mansueti laboratory. So that's the purpose of our talk today. So for those of you that are new here, just a little bit of background. So we were founded in 1925 by Reginald Truitt. He was a true visionary and in the sciences, and understood the importance of studying the organisms within the bay, things like the fish, the oysters, and the blue crab, and tying that into things like water quality conditions. So looking at a whole ecosystem approach to try to address some of the challenges that they were seeing all the way back in 1925. So as you can tell from the map, this is our 100-year celebration. So the lab was founded in 1925. And if you want a little bit more information, there's a QR code on the left there. This is the sign that's right outside of Bevan Hall that's on the front there that tells you all about the Chesapeake Biological Club and how we were founded. But there's also going to be a lot of events throughout the year celebrating our 100-year anniversary, and there's a QR code there, web address, so keep an eye out, and we'll have some more scheduled events. So we are the oldest state-supported marine laboratory on the East Coast, and we're part of the University of Maryland Center for Environmental Science. So our university is comprised of 6 different distributed laboratories across Maryland. We have a laboratory at the Horn Point Lab over on the Eastern Shore. We also have a laboratory, the Appalachian Lab in Frostburg, and then we're here in Southern Maryland. We also have the IMET, which is, anyone's been to downtown Baltimore, it's that big sail building next to the aquarium. That's the Institute of Marine Environmental Technology. We also Sea Grant, which is at College Park, and then the Integration Application Network, which is in Annapolis. And the advantage is that we're spread across the state. We study everything from the mountains to the coast, and we work on genes through the ecosystem approach as well. So we have a mission. Our university mission is to provide advice to state legislators and managers to preserve Maryland's resources. So this series is celebrating our 100 years, and this is unfortunately the last in the series. So we run these series twice a year, usually in April and October. And this one is just celebrating our 100-year history. We started out with our President Emeritus, Dr. Don Bosch. He's got a book out on our 100-year history. It's called Predictive Ecology. The QR code is there. It's also a discount code. And so he gave an overview of our 100-year history. And then you'll see, if you walk around, it's a wonderful evening. I hope you all got to wander around. It'll probably be dark when you leave. So but please come back to campus anytime. We like to name our buildings after some very important scientists here in our history, and those that have worked here, but also others that have been instrumental in Maryland science. And we have some of the oldest buildings here. So for the second series, Ralph Eshelman from the Calvert Marine Museum gave a history of Solomons, and it's absolutely fascinating hearing all about the history of Solomons here. We have some historic buildings. Our visitor center is the Solomon's House, and that's Isaac Solomon. That was back in 1780. We also have the Swift House and the Copp House. These are also late 1870s. These were where oyster workers, they were oyster packing company houses. We have the Parish House that you heard about the talk last week. This was the first place where Reginald Truitt was actually working out of a laboratory. Our first building here was, actually I'm not, did I? Okay, that's the next one. But anyway, we've got a lot of historic buildings here on campus that speak to, there was a general store, ice cream parlor, that's our Saunders House. Our nice hall, which is opposite here, That was in honor of Edna Nice, wife of Governor Harry Nice. Becker House on the corner here, that has 2 apartments and a education laboratory downstairs. That was a general store, living quarters upstairs, and then a laundromat. Well, in the third of our series, we talked all about our 100-year history in water quality monitoring. So we've been measuring parameters in the Patuxent River for over 83 years. And as you all drove in, you would have seen this sign here, our Solomon's climate sign. That is the actual data. That's the water temperature off our pier plotted over the 83 years from 1938 there all the way up to 2017. And that is just showing you the trend in the actual water temperature off the pier. I don't need to speak too much about it. The cold temperatures are in blue, the warmer temperatures are in red. But we actually have the Patuxent Centennial website. Again, the QR code is there. And that shows you all these different parameters that we're measuring. We started measuring just salinity, temperature. Now we're measuring much more complicated parameters. The one I love and use quite regularly is the sea level. You can see here a picture. This is where the tiki floods in front of the tiki bar. Last September, you can see that red line is what our scientists have found is that's likely to flood in the tiki bar area like this. And you can see for a 2-week period, every high tide, it was above that line. And again, science legacies here. We've had our last talk last week was speaking to Reginald Truitt. Dr. Tom Miller gave that in honor of our founder. So the Truitt Laboratory was built as one of our, it is our newest building, in 2016, dedicated to CBL's first director. We also had our first building was Bevan Hall, and that's the one at the front there. That was in 1931. My favorite is, of course, the Bernie Fowler Lab, where you're in now, honoring the late Senator Bernie Fowler for all of the work that he did in terms of advocating for, water quality and improved health of the Chesapeake Bay. So as I mentioned last week, we talked about our founder, Reginald Truitt, and just how instrumental his science was. He had such a breadth of science, all the way from studying physical oceanography, biological oceanography. Sorry, Tom, I stole your slide. Fisheries ecology, ecology and conservation. And he was very, very passionate about education and bringing in the communities. And he started this summer series. There's some absolutely amazing photos, like these ones below, showing these young scientists, the students, all coming together for these summer schools to educate them about subjects that actually weren't taught at College Park at the time. So looking at fisheries ecology, looking at the oysters here in the bay. And of course, I have to show this because Dave, okay, what are you wearing? So last week, you can see Tom went to great lengths. So this is the picture of Reginald Truitt. Notice the nice blue suit and the red tie. It's hard to see, blue suit, red tie. So thank you, Tom, for dressing up for the occasion. Now, our newest building is being built. You would have just gone past it right now. It's the Chesapeake Analytics Collaborative Building. That is a $22 million investment by the state of Maryland. And as Tom alluded to last week, it's been 30 plus years in the making. When I joined here 24 years ago, this building was being talked about. It was a library building. It's taken this long to get this building. Is now not a library building. It's a data analytics building. And it goes closely with one of the new initiatives at UMCES, the Chesapeake Global Collaboratory. And so you all know we're facing a lot of environmental challenges, and it takes everybody. We're all responsible in our part in trying to preserve our natural resources and our environment. And so what this collaboratory initiative is trying to do is bringing everybody together, novel approaches, innovative tools, bringing everybody together, not just the scientists, the agencies or the managers, but the public, the communities. Getting the right people in the room can often drive what the questions are, let alone the solutions to these complicated environmental problems. And then just because it's that time of year, just a pitch, how many of you got the Dolphin app? Dolphin Watch app, thank you. Come on, more hands. Okay, so this is the QR code. Please take a picture. And for any of you that are out on the water, or you can just be walking along Solomon's, how many have seen a dolphin this year? Excellent. And me, I saw one, but it's cheating because I was in Ocean City last week. But this is a program that's been running. It's the 8th year, and it speaks to how important you are as community members in helping us with the science. And so this app, it's a download for Android and iPhone. And if you ever see a dolphin, take a picture, send it to us. Our scientists actually verify that's a dolphin, and it goes into our database. And you can see here, this is telling us all about where the dolphins are. We can't be all across Maryland looking for this. So it's thanks to you, we have a much better appreciation of where dolphins are. What time of year are they coming into the bay? How far up of the bay are they coming? So please, if you don't have the app, please download it and send us your pictures of dolphins. We see some wonderful pictures. I mean, look, this dog just wants to play with that dolphin. We've seen pictures of dolphins that are flipping fish. We've seen birthing. We've seen all sorts of wonderful activities with dolphins. And then finally, as a, I have to finish on the ask. We support our graduate students through gifts and donations, helping them with their professional development, their studies, their research. And so there's a QR code, there's at the back of the room as well. This year, for this series, and in celebration of 100 years, I'm trying to do 100 donations. Could be $1, just 100 donations. And whoever pointed it out last week, 100 donations for 100 years. I'm not running this for 100 years. So English is clearly not my major. I am clearly a scientist. But and I want to thank you all for your support, for being here tonight, for showing us that science is important. And so thank you all for joining. With that, I would like to introduce our speaker tonight, Professor David Secor. His area of expertise is in fish ecology, all sorts of really fascinating work on how they can track different species using telemetry and trace element techniques, using oodoliths on fish and all sorts of things. Looking at a variety of different fisheries and protected species, and recently a lot of work in terms of offshore wind impact assessment. So with that, I'd like to welcome Dave and turn it over to you.
Can everybody hear me okay? I wanted to extend a warm welcome, a vote of appreciation to Marissa Mansueti Meyerberg and her family. Thank you very much for coming today. I hope I do justice by your father and your mother today. Okay, so where have we been? We have introduced the leadership of UMCs, and we have really benefited by that strong leadership in terms of how we've evolved and been resilient over these 100 years. And today I'm going to talk about Cronin in particular, who was kind of mid-span in our history and helped convey us through an important transition. Talk about that. And I also just wanted to highlight that half of UMC's history is here. This is where it started. And then we became much larger, and the other 50 years, 50% is UMC's. So we had a series of talks. President Bosch reviewed our entire history in his presentation emanating from his wonderful book, Predictive Ecology. Jeremy Testa showed the benefits of place-based research, that we have the seminal site, Sentinel site for climate change in the Chesapeake Bay off the pier. We heard from Dr. Eshelman about things that led to CBL, of older type history about fisheries and community here in Solomons. And then Tom gave this wonderful presentation about the creative and steadfast capacities of Director Truitt to develop something that hadn't been invented yet, a state-based station. And he went through all kinds of machinations to keep that going. And that was emphasized somewhat in Don Bosch's book. And today, my topic is Romeo Mansueti, who had a remarkable career during a critical nexus for CBL and UMC's. The CBL transitioned from a state institute to a new university institute. My premise today is that Mansueti set the standard for CBL science, that he pioneered 4 elements that President Bosch lays out as our central legacies at UMC's. And they're listed here: values of applied science, active dissemination of knowledge, immersion, not only in the natural community, but in our social communities to make what we do relevant, and then resilience. If we're going to be around, we need to take on the bumps and the turns that come our way. And Don provided evidence of these themes for our leaders, but we can definitely see it in our scientists as well. So that's what I'm going to try, is to work through these different themes in Romeo Mansueti's career. Well, what right do I have to talk about Romeo Mansueti? I never met him, and we're 2 generations distant. Here I am looking all nautical at the age of 6. And this is 2 years after Romeo Mansueti's seminal paper came out from his dissertation posthumously. Well, first off, like Jacques Cousteau, Rachel Carson, Jeannie Clark, Mansueti has always been a personal hero of mine. I've been so honored to build on his work at CBL. But also important is that Mansueti joined these heroes as part of the greatest generation emerging after World War II, carried with them a work ethic, patriotism, duty to their communities, and most importantly, I think, a faith and progress through the pursuit of knowledge and technological innovation. So who was Romeo Mansueti? And here I'd really like to thank Dr. Deidre Smith, who's a curator at Carnegie Museum of Natural History, who introduced me to things of Mansueti's career I had no idea, such as when he was on vacation, he painted this, I think it's a garter snake, and sent it to somebody he had already befriended, a curator, Graham Netting, at the Carnegie Museum of Natural History. That's pretty remarkable. It's a remarkable painting. And Deidre said she's going to put this on display at the museum in the near term. So he was initially a herper, and herpers are those that have a passion for amphibians and reptiles. And I've known herpers. I had a student who was a herper. We were driving the back roads of British Columbia looking for salmon hatcheries and all this, and he says, "Stop!" And I thought it was some emergency. He opens the door, launches into a bush, comes out with a snake, beaming. He's so happy, and I get to smell snake musk the rest of the day. That was a herper. And herpers range from our own stalwart Professor Chris Rao here at CBL, works on terrapins, all the way to Steve Irwin, the crocodile hunter. I don't know where Mansueti fit on this gradient, but he was definitely a herper. And as further evidence, look at this. This is just amazing to me. At age 18, he publishes a 64-page definitive volume of herps in the Baltimore area. This volume is reviewed by national curators. Look at the illustrations on these. I had to keep checking his birth year. I couldn't believe this at the age of 18. And then I love this. He lists 24 of his friends over 4 years to do the collecting. This is just truly remarkable example of mastering taxonomy, networking, illustration, natural history at a very young age. All right, so at 18, he's in college. He's at College Park. But then he joins the war effort. He was a World War II combat medic. He was in the Battle of the Bulge. He is recipient of the Bronze Star Medal. And he was unfortunately captured in a German POW camp for several months. Released and returned, he continued his undergraduate and graduate degrees, presumably under the GI Bill, at the University of Maryland. We heard from Tom last week that Truett was a good talent scout. And I don't know how they met, but I'm sure when Truett saw him, he didn't let him go. Because Mansueti was exceptional, as we've already talked about. So he started during his matriculation at College Park, and he rapidly advanced to senior fishery scientist at CBL in 1950. At the same time, he was working on his PhD, which he received from Hopkins in '57. Of course, he had other interests: photographer, illustrator, naturalist, musician, as did his wife, Alice J. Mansueti, later Lipson, renowned scientific illustrator, naturalist, and ecologist. He had a sudden death at the age of 40 and survived by Alice and 3 children. As I mentioned, Romeo's career spanned this transition at CBL, where we moved from a state institution to a university. So let's see what it was like when Mansueti worked. And we fortunately have this very nice document from 1963 that can help. I'll introduce that later. But we also have these wonderful books. We just have a treasure trove of history in our libraries here at CBL. And one of the survival mechanisms that President Bosch mentioned that Truett had to use was to move CBL, which was kind of this consortium of universities that were assembled and by Truett, to a state department called Maryland Department of Research and Education. This was maybe an uncomfortable fit. For instance, in 1960, you can see the budget layout that we were competing with tidewater fisheries, game of inland fishes, forests and parks, geology, mines, and so on. And even the budget that went to our department, a lot of that went to other entities within the department. So Cronin had to go year after year and compete for these funds. Reporting to the state, the department and CBL had an uncomfortably broad remit of fins, feathers, furs, forests, swamps, mines, weather, and hydrography. You see why I had to read all that. And this competed with emerging research at CBL and population dynamics, ecosystems, and toxicology of metals. And further, we were really an outfit of scientists, much more than the other departments within the board. No doubt, Cronin saw also what was happening at the University of Maryland and other universities, that after the war, the federal government was investing heavily because the war effort proved the value of science and engineering and societal progress. So we had things like the GI Bill. We had the National Science Foundation Act in 1950. And to best take advantage of these opportunities, it makes sense to move from a state department to the university. Well, I'm pleased that I work in the Cronin Research Building. Cronin deserves a lot of credit for being prescient and navigating CBL back to the University of Maryland as the Natural Resources Institute, a new entity, which came about in 1961. This allowed greater autonomy and reporting directly to the president of the university, ease collaborations with other Chesapeake science institutes. But Cronin still had some struggles. He had some space problems, and after a big chunk of the staff that were the inland game staff were transferred to Annapolis, you can almost hear a sigh of relief in his statement that CBL is now back-centered in estuarine science. A CBL report in 1963 gives insight into what the lab looked like. CBL science was focused on Chesapeake Bay living resources, as both Tom and Don featured in their talks. But a range of emerging issues were also covered: toxicology, power plants, invasive species. Noteworthy also is that CBL scientists were procuring very large awards in 2025 dollars, on the order of $1 million or more. I found a nice thread, a connection to Mansueti's NSF grants, one on white perch life history. Early in my career, I had a similar grant. I'm glad that NSF didn't check. All right, here I've compared 1963 personnel to our current staff. Professional scientists, not all of them had PhDs, the majority did not, but they were basically equivalent to our current professorial rank, and the numbers are equivalent. We now depend on a lot of technical help from our faculty research assistants. Probably historically, the professional scientists did their own work. Interestingly, administrative and maintenance staff are kind of equivalent. You would expect them to be a lot more these days because bigger plants, so on, it speaks to increased efficiency, perhaps. And we really can't compare students because there wasn't a grad student program back then. So we had equivalent amount of staff here at CBL, which is kind of surprising. It's not a sleepy place as I might have expected, but we have a much smaller footprint. And the yellow block shows the campus in 1963. So basically 3 buildings, what's now Bevan, Corey, and Nice. They all had to kind of scrunch in there. Now, they were very happy at the time about this new research building. It was called the new research building, and now it's called Corey. But they were really excited about that because prior to that, they had just been in Bevan and Nice. So you could tell there was a space crunch because as soon as Corey Hall or the new research building opened up, you can see each one of those compartments is already spoken for. Everything is divvied up. You can see a lot of, I can see a lot of sharp elbows across those individual compartments, which are no longer there. But each one was assigned a lab. It's interesting to look at how the labs are all identified by different topics and their PIs. Tom, by the way, featured that general exhibit room with the tanks in Bevan last. Okay, so let's get back to Romeo Mansueti. First off, what did he do for his day job? As part of the Department of Research and Education, there were important and required public services given over to CBL scientists. And here are some correspondences and testimony related to those duties. I found it interesting that during a formal era, Mansueti would address the director of Tidewater Fisheries by his first name, Joe Manning. But it turns out that Joe and Mansueti were colleagues for so many years here at CBL before he moved up the ranks. This was also true for another leader in the Board of Natural Resources, William Bailiff. He was also here at CBL. So CBL, early in its history, had a formative year in placing environmental leaders within the state. Mansueti was also charged with collecting landings data, public outreach, and serving as lead state naturalist. And looking through CBL reports during this period, I noted that the day jobs consumed all the activities of many of Mansueti's colleagues. They could be all consuming, likely to the detriment of the science that they might otherwise pursue. And somehow Dr. Mansueti managed to achieve beyond his day job, as noted in this obituary. Right. Okay, now for some science. It's a nice day out. It's maybe May. Let's go out on a boat and collect some plankton. Not so hard. Get a plankton net, tow it behind you. But what happens when you do that? This. The water has all kinds of gunk in it. We call it detritus. And it's miserable stuff. If you work in lakes, the ocean, you have to deal with it. You work in the Chesapeake, you got to deal with this detritus. So in this detritus, it's hiding someplace on these beautiful little fish larvae and eggs that we've got to uncover. And that's first and foremost what Mansueti was famous for, is finding these hidden lives of striped bass and white perch. So get to this stage, to find the larvae in this gunk, it's going to take you probably a day or longer. So it is a lot of hard work. But Mansueti, who really didn't have the experience that I did, saying, oh, Mansueti did it, I can do it. He was the pioneer doing this. And he was able to do it undaunted by this hard work. And that work paid off. 62 years ago, Mansueti and his colleague Hollis first summarized where striped bass spawn in the Chesapeake Bay, a seminal achievement, work that still informs conservation and management. You know, and look at this illustration. You know, I'm old enough to have done the acetate and the Castell pens and the press-on stuff, and you do think twice before you enter into that kind of effort. Mansueti does, they're basically infomatics. There's so much information in this. He shows you what he's looking for in the upper corner. It's mapped, so it shows the distribution of where spawning is occurring, different hatches showing you different years and different investigators. And then you can see they're all delimited down the lower part of the estuary. And that was very important observation that Mansueti made. He noticed that the spawning areas where he found eggs, they would be pushed down in wet years and they'd be pushed up in dry years. And he said that the salt line is determining where the spawning starts, the salt line. And this idea was picked up later. It's termed the salt front, and it turns out to be quite important. The salt front and estuarine circulation concentrates nutrients, accelerates food webs, provides ideal nursery conditions for first feeding larvae. Ideas initially proposed by Mansueti's colleague Bill Doval and later pursued by many of us at UMC's under the leadership of Professor Emeritus Ed Hood. Now, Mansueti is an illustrator, often cast the scientific results onto maps, as we just saw. Fish use different parts of the Chesapeake Bay for different functions. This is not just about where we're going to catch the most fish, but linking key parts of the Chesapeake to living resource production and sustainability. This interest in spatial ecology ushered in the era of power plant siting, where it was important to link local stressors to living resource impacts. And the focus on living resources within these seasonally dynamic seascapes has been sustained by work of later UMC scientists, but perhaps none so impressive as Alice Lipson, who amazingly, in 2 dimensions, represents seasonal habitat dependencies, all of life's history stages of key living resources in the Potomac River. Representations never repeated. That's that diagram over there. I mean, it's just remarkable, the ambition to even to try to do something like that. And I have some of those maps displayed in the back if you want to take a look at them. They've really never been repeated. All right. While we are speaking of Alice, or AJ, I'd like to talk about a shared vision she had with her husband that took the form of a successful NSF grant. Her illustrations deriving from the muck were unparalleled. Just amazing. She had to use her imagination. These things are coming out in all different bad conditions. She had to pick the best ones. She had to kind of imagine and line them up in series. And there's these beautiful illustrations that represent a deep knowledge of development and metamorphosis. And what I really like is in her mind's eye, she imagines big explosive events like the egg hatching. You look in the upper corner. You don't find that in this muck. She had to see that in her mind's eye and represent that in a realistic way. Very, just amazing work. All right, so they wanted to not only do it for a few species, but they wanted to do it for all the fishes of the Chesapeake Bay. So they proposed this to NSF. And it's kind of fun to read the NSF proposal. It's just like now, we really lay it in when we want to get our funds. And what Romeo was saying, listen, we're behind the Europeans, but we're really behind the Russians. In other words, we can't lose the larval space race. So they got funded. Well, unfortunately, there was a tragic turn in all of this. During the course of the project, Romeo passes away. And in this heartrending final report, Alice, several months mourning the death of her husband, 3 young children at home, must complete this work as sole project leader in the shared vision. It's just remarkable. Yet not only does she heroically finish the project, but moves the vision forward with J.D. Hardy to a much larger project, a 6-volume reference for over 300 species, not just the Chesapeake Bay, but the entire mid-Atlantic. A.J. Lipson, after marrying fellow CBL scientist Robert Lipson, carries on with her own illustrious career in natural science and communication. Pun intended. Now, into the other element that study is famous for, studies on striped bass migration. Tom mentioned predecessors Vladikov and Wallace and all the thousands of striped bass, but their study was biased. They concluded that striped bass did not leave the bay, and one of the problems was they weren't well networked outside of the Chesapeake. If you go and tag a lot of fish, you got to depend on somebody to report them back. And if all your buddies are in the Chesapeake, you're not going to get any calls from Massachusetts. Mansueti was really well networked, and we could see his networking skills from the age of 18. It was 24 volunteers. So Mansueti revisited this, and he came up with a very different conclusion. Striped bass did leave the bay, but they did so related to their size. And again, look at this. I just love these figures he produces. He has the map. He always likes the map. But on this axis, we have miles migrating, up to 700 miles. And on this is the length of the fish, on up to 45. And then he has this little inset showing what's going on in the Chesapeake. The smaller fish are in the Chesapeake, but even the smaller fish are migrating in a size-dependent manner. But all those points out in the ocean, he's got them where they are. They're supposed to be. It's demonstrating they're in the ocean. He's also demonstrating that they're big. So like the spawning map, I can understand this as an expert, and a layperson can understand this. We don't need a paragraph legend under this figure. It's just so refreshing to come across figures that are so demonstrative. But he was circumspect about his results. He still had very few recaptures outside the Chesapeake. He said more research needed to be done. So I took that as my calling card many years later. And over 25 years, I worked up to get a large electronic tagging study. Electronic tagging, we don't have to rely on the reporting of fishermen to get detections of the fish. So what we find is that we tag fish in the Chesapeake, just look at the dark dots and day of the year season. So they leave in spring and they head up off Massachusetts in the summer, and then they migrate back down south. And these are long tags, so we get this year after year, just like birds. Isn't that great? But look at the gray dots. The gray dots are staying in the Chesapeake Bay year round. Those are our small fish, less than 30 inches. Why'd I have to do the study? Mansueti already knew the answer. That's nice to confirm. In both his white perch and striped bass work, Mansueti strived to integrate the new information he's collecting on age, growth, mortality, reproduction, recruitment, into a common framework to support management. Here's this very nice quote: reliable prediction of future crops of striped bass and the estimation of population size of catchable fish are inestimable value. Actually, they are estimable. Sorry, inside joke. To fishermen, managers, and conservationists. That's a great quote, and it's so ahead of its time. Further, that plot, we call it cohort analysis or virtual population analysis. He stumbled across this, just trying to plot out how good years of reproduction moved into age classes by abundance. And this was many years before virtual population analysis became a common used tool in stock assessment. So one can't help but wonder if he had had a longer career, we would have moved much more rapidly into quantitative stock assessment scientists. As it is, we didn't return to that topic really until the 80s. And ever since, we've had a very strong program here at CBL on stock assessment. Here's a recent example of Dr. Samara Nehemiah's work with Dr. Wilberg, looking at trying to bring migration into the stock assessment framework. I think Romeo Mansueti would have really enjoyed that work. Okay, one last thing on science. He was also prescient on issues of nutrient pollution and living resources, hypothesizing that anthropogenic nutrients might actually promote production of striped bass and other pelagic fishes. Again, it would be many years before this idea was picked up again. And here's an analysis that Professor Boynton was involved in, and Professor Hood, where you do see some evidence that over the decades of increased nutrient pollution, we see increased abundances of planktivore or pelagic fishes. We have to be careful of this. If you watch Walter, always watch the hands. That's like half the story. Sorry he's not here, but it's always, and what Walter's, I'm sure what he's saying here is, it's a balance, a trade-off. And, you know, too much nutrients obviously is not a good thing and can lead to increased incidence and extent of low oxygen conditions. This great quote by Mansueti: "There is an urgent need for the construction of a huge model of the Chesapeake Bay watershed to investigate various problems, hydrography, pollution, fertilization." Again, very prescient, but this isn't, there's no computer models then. There's no Chesapeake Bay model. There's no simulations. He was talking about a Legoland model, and they eventually built one called the Chesapeake Bay hydraulic model in the 70s. All right. So moving on to active dissemination of knowledge, Mansueti was a very committed writer and editor during his career. And as somebody who obviously enjoys history, I was really impressed by his scholarship. This isn't where we can get everything on the internet immediately. And in this 100-page tome on the history of American shad fisheries in North America, I don't know how he got to original sources. It went all the way back to the colonial period, very exhaustive. And he's so versatile that he can write that and then pivot immediately and write this very nice illustrated public outreach piece on snakes. Yeah. As President Bosch mentioned, Mansueti stood up the Journal of Chesapeake Science, which later became Estuaries, and Coasts. Make up your mind. But he was their first editor. And imagine trying to stand up a journal for the first time. How do you get people to read it? How do you get authors to contribute? Well, he did this by being a principal contributor himself. The early volumes, 15% of those papers were his own. He published his best work. He published his dissertation work, but he also published a range of other things. Sound production, Gravel Jack, Bonito, up in the Upper Bay is an anomalous occurrence. He developed, he encouraged book reviews and themed series. He was also the ichthyology editor for Copea, which is the from the Society, the Journal of the Society of Ichthyology and Herpetologists. And Mansueti was immersed, not only in subject matter, but swamps. He never met a swamp he didn't like. But he particularly liked Battle Creek Cypress Swamp, located just south of Prince Frederick. This is the northernmost stand of bald cypress, and Romeo worked with state leaders and the public to raise funds and lobby the Nature Conservancy to purchase and preserve this swamp. So much like we heard Truett's Lake role last week in Massapequa National Seashore, Mansueti had an outsized community role in preserving this wonderful swamp for future generations. And I don't know if you recognize Romeo, but he's clad more appropriately for being in a swamp. Fellow with a hat. All right. Turning to resilience, I suggest that although Mansueti's career was abbreviated, informed, and inspired generations of sea scientists, his legacies are clear, and one can only wonder about how his emerging interest in stock assessment and nutrient pollution would have played out. What might he think of CBL now? Well, here I think it's useful to consider the statement of character in his memoriam. In his personal name, Dr. Mansueti was difficult to characterize. He was serene and introspective, at the same time dynamic and forceful, and for the respect of all who knew him. It was interesting that Tom spent some time last week on the character Truett, and I would say comparatively, from my perspective, Mansueti is much more relatable. That this statement, serene and introspective, I think that would resonate with a lot of the faculty here, for instance, at CBL. It's a wonderful way to be. But the last statement is what I want to turn to now, is that no aspect of biology escaped his avid attention. What Mansueti and Truitt left us with was a legacy of all of the above pursuits. And this remains central to CBL, a mix of reactive and proactive science not easily captured by a single strategic direction or discipline. What do we do at CBL? Well, certainly fishery science, contaminants, toxicology, but wait, we have a world famous program in systems ecology. Also, we do fantastic Arctic science, and there's our data science concentration. Oh yeah, Green Harbors up in Baltimore. And there's a rainforest watershed restoration person, microbial extremophiles. Also, we train territory students throughout the United States, island territory students throughout the United States into marine science careers. And we have a long-term program in offshore Maryland to monitor migrations, whales, dolphins, sharks, turtles, and fishes. No wonder Karis's introductions are so long. I can easily come up with a few word statement on each one of our sister labs. It's so easy. They're so nicely defined. It just isn't possible. Our tent is too big here at CBL to do likewise. All right, back to Mansueti. What does President Bosch say about Romeo Mansueti? Mansueti became a renowned scholar of the eggs, larvae, and young of fishes, the Mid-Atlantic region. Brilliant, versatile, incredibly hardworking, and prolific. During his 13 years at CBL, he earned a national reputation with a meteoric rise in notoriety. And I don't think President Bosch is meaning to imply that that's just redounding to him. It redounds to the lab, redounds to the center. They really did up our game. Mansueti set the standard for UMC's scientist exemplar. Applied science is necessarily interdisciplinary and difficult. He did not shy away from this. He immersed himself in both the natural and human communities of Southern Maryland. He set high marks of achievement, science dissemination, and was deeply contemplative, resulting in present views of future Bay issues in science. And of course, he's honored by this named building. You know, it's really not the best looking building. I'm sorry. You know, it used to look a lot better. I wish we could return to those days. That's a homage to Bob Ulanowitz. Many of us were very sorry when that tree went down. But Mansueti does hold very important functions. It is our administrative heart, and our IT program is centered there as well. And appropriate to Mansueti's scholarship, that's where our library is. Now, bit of a surprise ending, at least to me. There remains an unrecognized Mansueti legacy, even though with this named building. And that is that the Mansueti legacy is one reflecting both the partnership and individual achievements of RJ and AJ Mansueti and AJ Lipson. In my research, it became clear that many of Romeo's plans and achievements resulted from his partnership with Alice, and much of his legacy rested on her shoulders following his untimely death. Further, Alice Lipson has a long and esteemed career as an esteemed independent scientist and naturalist, but that's another story. Thank you very much.